welcome to my YouTube channel. Good day, everyone. My name is Precious. Okay, so in our last very lesson, we looked at the next step on solution of systems of equations. All right, so we started looking at the major steps of solving. First of all, we saw what a solution is. We saw the different types of solution. We saw the cases where you can have no solution, and we saw a case where you can have a unique solution, and we also saw a case where you can have many solutions. And then we went down to look at the Gaussian elimination, and I said that it involves two broad aspects. One is reducing a system into a triangular form, which we can also call row reduction, and then, or you call it triangular reduction, all right? So, and then I said the second part is what we call the backward substitution, all right? So the coming together of these two processes is what makes up what we call the Gaussian elimination. The thing is that in the end of these two processes, you would have gotten the values of your variables, all right, which forms the solution to the system. Okay, so and then we saw an example where the reduction was already done, and so we are just expected to do the backward substitution, which we have done. And so if you have not seen this video, the one I'm talking about, you kindly check the video before this. I think that should be that. Okay, so and then in today's lesson, or in this particular lesson, we're going to now be looking at how do you do triangular reduction. So this is the example is going to involve both the triangular reduction and the backward substitution. Of course, the both is what I have said makes up the Gaussian elimination. Alright, so now here, these are the steps that you are allowed to take, under Gaussian elimination. You can take any of these steps, and there are others that I can say even as we go on. One of it is that you are allowed to interchange equations. You can see here, this is an example. It says we should solve the system minus 7x1 blah 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 up to that, about 3 equations in 3 variables. Alright, so you are allowed to make equation 1 to become equation 3, and equation 3 to become equation 2, and equation 2 to become equation is allowed at any point. And I will tell you why you need that. For example, look at this equation. When we will start forming our elimination steps, you will see that it will be easier to eliminate or to do your elimination when the equation 2 here is equation 1. It's always better to have your x1 or the leading variable to have a coefficient of 1. Right? I just made mention of something. Of course, I'm going to explain that. We have what we call the leading variable and the free variables. Okay, so for every row, there is a leading variable and you have the free variables. Alright, so for here now, this is our leading variable. So x2 and x3 are free variables. Alright, so now it is expected that your leading variable will always have a coefficient of 1. It makes it easier to do your elimination. That doesn't mean you can't do the elimination even if it is not. So, but in a case where you can get that, it is better to take that route. Okay, so with that in mind, I can now say let equation 2 become my equation 1, and let equation 1 become equation 2. That is allowed. And then the second thing here that you are allowed to do, which forms some of the steps of triangular reduction, is that you are allowed to multiply any equation by a non-zero constant. Any non-zero constant. So I can choose to multiply through this by maybe 1/7 or minus 1/7. If I multiply by minus 1/7, at least it will remove this coefficient here. But the only thing is that it will now make this other two to become fractions. And I don't want fractions, because fractions, it's not as though also we can solve with fractions. Then it is better to have whole numbers. So I will leave this way. But if there is a case where multiplying through by a constant will help me achieve what I want, then it is allowed. The only thing is that it must multiply every single term in that equation. So for instance, if I multiply here by 2, this one will also be by 2, this by 2. Everything must be multiplied by 2 as well. Alright, so now with that, now the last one here is that you are allowed to add or subtract a non-zero multiple of an equation to another. That means I can multiply one equation and add it to another equation to form a new equation so that I'll be able to do the elimination that I want to do. Alright, now with all of this in mind, let me now let us know what actually you want to achieve when you're doing Gaussian elimination or when you're doing triangular reduction. Is that you want your system to be in triangular form. You don't want the block form. So that is to say, for this equation, I would like only the equation 1 to have x1. That means in equation 2 and equation 3, I will eliminate x1. And then when I come to the second column here, I will allow only equation 2 to have x2. Then that means I will eliminate x2 in equation 3. Let me do a quick thing here. The implication is that if I do that, you will see that this is going to be triangular in nature. And so it will immediately form what I want to get. Then of course you cannot come and clean it this way. So what do? You will do the elimination following mathematical processes. And these are the processes we are showing you here. So the first thing is that I would like to do that interchange. So now it will be good we give some nomenclatures here because it will help us. Let me call this E1, equation 1, equation 2, and equation 3. Okay, so at each point of our process, the equations might change. Okay, so let's go now. So the first thing I want to do is that I want to let my equation 1 to become equation 2 and let my equation 2 become equation 1. If I do that, what I'm going to achieve is that my system is now going to be x1 minus x2 plus x. Alright, so I've achieved that command. It's like a command. It's like programming. So you are giving a command, and when you give the command, you try to achieve it before giving the next command. So what's the next command? I want to eliminate x1 from the equation 1 and equation 2. So that means my equation 1 will remain the same. So I'm going to only write a formula or formulas that will eliminate x1 and x1 in equation 2 and 3. But my equation 1 will remain the same. So see what I'm going to have. I will now say, let my new E2 now become, so I will look for a way to do this elimination. Of course, in doing this elimination, you will use E1 to do it. So I will say, how am I going to multiply E1 and maybe add or subtract it from E3 or subtract E3 from E2 from it to give me 0 so that I will get 0 so that I will eliminate this and see what is going to be. If I multiply E1 by 7, this is going to become 7x1. And then if I add it to this one, of course, minus 7 plus minus is minus. So I will have 7x1 minus 7x1, and that will be 0. So that means here will be eliminated. So in other words, remember this is what is guiding me in writing the formula. So this is now going to become 7e1 plus e2 will help me to eliminate this. I don't care what happens to the rest. Only thing I'm interested is in eliminating this in equation 2. So this is going to be my new E2. That's what did I apply now? I'm applying this 2. You can multiply an equation and you can add or subtract it to another. So I've multiplied equation 1 by 7 and I added it to equation 2, and I want to call that addition my new equation 2. So that is to say, okay, I'm done with this, so I'll go to equation 3. Now by the time I finish doing this, in the next step, you will join me in writing. You will pause your video a little bit and then write the algorithm. So what are we going to have as our new E3? I want to eliminate this. So this, you can see now why it is good for the coefficient of this to be 1. So all you need to do is take this coefficient, use it to multiply this. So if I take 6 and multiply this, I'm going to have 6x1. And of course, 6x1 minus 6x1 is what? 0. So that means just multiply E1 by 6 and subtract E3 from it. And that will give you something that will eliminate x1 in the new E3 that you have. So if you watch now, of all the algorithms I've written, it's only E2 and E3 that changed. So my E1 will remain the same. So C1 is going to be my new system now. So the new system is going to be E1 will still be x1 minus x2 plus x3 equal to 8. And then my new E2, I will now apply this. So let's apply it. If 7 multiplies this, what are you going to have? You can actually do this somewhere else. But of course, with time, as you get used to it, you can just be doing it alongside. So if I multiply 7, that means 7 will be here, 7 will be here, 7 will be here. 7 times 8 will give me, I think, 52 or 56. Okay, so quickly, let's do that. So 7 times this is 7x1. And if I add it to this, I'll get 0. So here we go. Here will be minus 7x2. If I add it to this, minus 7 plus 4 will give me minus 3x2. Then plus 7 here, 7 plus 2, that will give me 9x3. And then I have 8 here, 7 multiplying 8. Okay, so 56, I will add it to 11, and minus 11, and that will give me 45. Okay, so that means I've eliminated x1 in the new equation 2. I hope you are getting what we are saying now. So the new equation 3, I will also eliminate x1. Let's watch it. So see what my new equation 3 is going to be. I'm going to apply this algorithm. So I will use 6 and multiply all x1. So this will be 6x1. 6x1 minus my x3, which is 6x1. That will be 0. Then minus 6 minus 2 is going to become what? Minus 8. So remember, you are having minus 2 here. So that will be minus 8x2. And then this will be plus 6. Plus 6 minus 7. So you have 6 minus 7. That will be plus 7. Which is what? 13x3 is now equal to, here 6 times 8 is 48, and then 48 minus 28. So I have 48 minus is plus 28. That's going to be 6. Of course, I have 7 here, and that is here 76. So you can see now the elimination has happened. So your x1 has disappeared in both equation 2 and equation 3. And so what is next? So next, you can now check what you can do. So because of one of those methods that says you can multiply any equation, so that, and of course you know multiplication can be by the inverse, so I can multiply by 1 over or minus 1 over 3. You can watch. Why am I doing that? Because I want the coefficient of, remember I talked about free variables and leading variable. This was the leading variable in equation 1, and in equation 2 now, this is our leading variable. The leading variable is the one you will use to eliminate others. So if I want to eliminate x2 in equation 3, this becomes my leading variable. So I want this leading variable, that's x2, to have a coefficient of 1. So, and it is possible. If it is not possible, I will use it that way. Then here it is possible. So I can divide through by minus 3. So if I divide through equation 2 by minus 3, see what? Now, I don't know if you want me to write a new equation or I can just apply it here. If you allow me to apply it here, so this is going to become, if I divide by minus 3 here, this will go. If I divide by minus 3, this will become minus 3. And then if I divide here by minus 3, this will be minus 15. Okay, so with this now, I can now get my new algorithm. Remember that the new algorithm will just be for E3 because you only want to eliminate x2 here. You want a triangular form. Okay, so the new E3 will now become what? So like I said, it will help me to form this. You can pause the video at this point and try to form the algorithm. Let's see what you get. Alright, so but for me, what is it going to be? You can see all I need to do is use this to multiply this. So if I multiply, I may use the positive or the negative, any one, but it's good we use the positive. So let's use 8 to multiply E2. So if we do 8 times E2, so since it is positive, what will you do? Is it plus or minus? So it should be plus. So if I do plus, of course, plus 8 plus minus 8 will be minus, so they will still cancel. So you just add E3 to it. So now, since it is only E3 that has a new algorithm, it means that our E1 and our E2 will remain the same. So let's write that. So my new E1 will be, my E1 remains the same, minus x2 plus x3 equal to 8. And then I have x2 minus 3x3 equal to minus 15. And so what will be my new E3? Now let's apply that. Multiply everything here by 8. So if I multiply x2 by 8, that will be 8x2. If you add it, you will get 0. So this will go. Multiply here by 8, that will be minus 24. Then add it to 13. Minus 24 plus 13 will quickly give us minus 11x3. And that is equal to, then lastly, multiply 15, minus 15 by 8. Okay, so if you multiply minus 15 by 8, that will give us minus 120. And when you add 76 to it, which is your E3, that's going to be negative 44. Okay, so, and you are done. You have achieved the triangular form that you are looking for. Remember, in the triangular form, all you need to do is the leading variable should have none under it. The leading variable should have none under it. So this is the last leading variable here. Of course, there's nothing under it. Okay, so, and we have achieved our triangular, or what we call row reduction. Okay, and so the next will be to just get your backward substitution to be able to get the values of x1, x2, and x3. So what do you then do? So backward substitution. So for our backward substitution, we'll start with equation 3. This is our new E3. So I will just pick my minus 11x3 equal to minus 44. Divide both sides by minus 11. So x3 alone will be minus 44 all over minus 11. And that is equal to positive 4. Because minus will cancel. So your x3 is plus 4. And so the next is to substitute it into equation 2. Your equation 2 is x2 minus 3 into x3, which is 4, equal to minus 15. And what is our this? So this will be x2. This times this is minus 12, equal to minus 15. If you take this to the other side, x2 will be minus 15 plus 12. And that is equal to negative 3. Okay, so we have gotten plus 4 and negative 3. So finally, if we substitute into equation 1, we substitute x2 and x3. So this is going to be x1 minus my x2, which is minus 3, and then plus my x3, which is 4, is equal to 8. So this is going to give me x1, of course this is plus 3 plus 4, equal to 8. If you add this, you have 7. So this is 8. Bring this over, will give you minus 7. And so our x1 is equal to 1. Therefore, the complete solution for this is x1 is equal to 1, x2 is equal to minus 3, x3 is equal to 4. And so you can put it in a bracket form, 1 minus 3 and positive 4 as your solution set. And of course you can see that this is another case where you have a unique solution. There's no other solution for this. Alright, so this is what Gaussian elimination is all about. Of course, we will do another example to ensure that this is well understood. Okay, so it starts from you being able to interchange, and then you can multiply and add, and you can divide an equation, whatever. Just make sure it is mathematically correct. And all you are focusing on is, I want to eliminate x1 from the first column. All x1 after the first equation, you eliminate all the x1. In the second column, after the second equation, the x2 there, every other x2 below it should be eliminated. If there is an x3 under this other x3, you also eliminate. So once you are done, whatever you have is your triangular form. And then with that, you will be able to now, do a back substitution to get the remaining equation, to get the solution for your x1, x2, x3 as the case may be. Alright, so this is where we will stop it for this video. In the next video, we are going to do more examples on how to use the Gaussian elimination, and then we will now see cases where you will have infinitely many solutions and where you will have no solution at all. We will see examples and cases like that. Alright, for this video, we will stop here. Kindly subscribe to my YouTube channel and do share, make comments. If you watch and you like the video, please make nice comments and share our videos to your friends, your colleagues in class, and we'll see us in